Hello everyone, this is KP the Math G, and in our last lesson, this is part 1, we want that to be part 2 actually, because in part 1 we derived these, not all 6 of these, but we took the derivative of sine inverse, tangent inverse, and secant inverse. And notice that actually cosine inverse is almost the exact same as sine except for sine, and the same thing for tangent, and the same thing for cosecant. So that's the reason I only did 3 of these. But now I have the formulas here. Now, will you have them available to you? Probably not. I just don't know that for sure, but excuse me, you're just going to have to commit these to memory. And I think one of the things you can think about is the only ones that have plus signs, that everyone's going to have a 1, and everything that has a C in it will have a negative sign in front. The only 2 without square roots and plus signs will be tangent inverse and cotangent inverse. Okay, all the u's will be squared, and the difference in sine and cosine is not any. 1 minus u squared, 1 minus u squared, and then this is u squared minus 1 for secant and cosecant, but they have a u in front. I kind of like to think of it as if I'll go ahead and start my u, and then I have to have a u, so I put those 2 u's side by side. See, that's the way I'll memorize it, but just kind of think of it that way. We're going to do, I want to say 4 derivatives of inverse. I want to say we're going to do 1 with sine, 1 sine inverse, 1 with cosine inverse, 1 with tangent inverse, and 1 with secant inverse. Not to say that we couldn't do anything with cotangent inverse and cosecant inverse. We just want to pick 4, and if you can do 1, you can do any of these. Really and truly, you can. Well, let's start here. Let's see. I want to find the derivative. That means the derivative of sine inverse of 7x. So let's do this. There's the formula right here. Alright, so I'm going to say, okay, that's equal to 1 over the square root of 1 minus u. This is u. U is equal to 7x right there. Alright, so it's going to be 7x squared times the derivative of, so we're going to just do kind of like a chain rule here. We'll take that derivative here. So on the next step we'll have it. I could have done it right here, and probably from now on I will, but I just want to show this just for emphasis sake here. Alright, so that's equal to 1 over the square root of 1 minus 49 x squared, and just leave that like that. That's good enough. The derivative of 7x is just 7, so I'm just going to put the 7 in. This is in the numerator anyway, so this is just 7 up here, and that's it. Okay. Alright, and that's how you do it. That's what you do there. Just so we know, this was 1, 7 over 1 here, and then I just multiply that out. If you want to just go ahead. Okay. And most of the time your derivative of this will be in the numerator. That's what you're going to find here. Okay, that was a fairly simple one. So that's pretty much what you do. You just plug it in and then take the derivative of what you just plugged in, and that's it. Okay, so let's go ahead and do another one. They get a little more let's think what I'll do is I'm going to skip cosine for now. The one for cosine is a little more difficult, so I think I'm just going to go with tangent. Okay, so here we go. I'm just going to do, this will be number 2. Find tangent inverse, that's derivative of that, of 8x to the 4th power. Now we want the derivative of all this. Okay. Alright, so we're looking for tangent. That's 1 over 1 plus u squared times the derivative of u. So, okay, we know that u is equal to 8x to the 4th. Alright, here we go. Let's do this. Okay. It's going to be 1 over 1 plus, okay, 8x to the 4th. We're going to square that. Alright. That's part of it. And now we're just going to take the derivative of 8x to the 4th and put it over here. That's going to be 32x cubed. And then that's basically it right there. Okay. And if you want to, we do need to probably clean this up a little bit. So that does equal 1 over 1 plus 64x, 4 plus, well, 4 times 2 is 8 here. Okay, like that. Alright, 8 squared is 64, and then 4 times 2 is 8. And if I want to, I can put the 32 right there. Alright, do not make a mistake and decide that you're going to divide out 32 and 64 and x cubed with x8, because this is really treated as one term right here. Okay, it is 2 terms, but it's treated as 1 unit. So you don't have anything to divide out over here as well. You only have something here, but you can't do that because these two go together. Okay. Alright, so anyway, there's that one. Alright, so that's what you do there. And I'm just double checking, I'm making sure. Alright, let's do the next one then. Alright. Pretty good examples, aren't they? I mean, it's pretty straightforward, I think. But you do need to know these formulas by heart if you, probably when you're taking the exam, you probably need to know these. This has magnets on the back, but I think they're too far embedded in there. Ah, it held this time. What do you know? Sometimes this thing will fool me. This eraser, that is. Okay, so now. Alright, so let's do something. And I want to say that when we say this dash here, we could, this here, we could very easily put arc something, and I'm going to do this on the last 2 examples. So really we could say arc, and we're going to do cosine of tangent cube x. Alright, we want to find the derivative of that. And me and my grandson are in the way, but we're going to just put that dash right up there like that. And leave them sitting right there. I don't know if you noticed that. That's a picture of my grandson and me right there. And I probably could have scooted that over just probably 8 or 10 centimeters over. Oh, well, it doesn't matter. Okay. And again, this is the same thing as saying I want to find cosine inverse like this, and then I could have done this. And what we've been doing is the exact same thing and do like that. This right here is the same thing as arc cosine like that. So just make sure you understand that there is no difference in that. So I'm going to erase this, and we'll start with the. I just don't want any students to see arc cosine or arc secant or whatever, and I don't know what that is. Well, that's just the inverse of cosine. Alright, so let's do that. See if this, oh my goodness, you're doing so well. Alright, here it is. Here's the cosine. I'm doing arc cosine, so here it is. It's, alright, so -1 over the square root of 1 minus, and of course u here is tangent cubed x. Alright, so this is what we're doing. We're going to put tangent cubed x like that, and then we're going to take the derivative of this, so we're going to put that right here. Oh, we need to square that, don't we? See, that says square that. Okay, so we are going to square that. Alright, so we're going to take this derivative, so 3 tangent squared x. Remember, we reduced the exponent by 1. Alright, now we need to take the derivative of tangent squared, which is secant squared x. You know, one thing that I have found in calculus and in trying to teach calculus, and that is you need to know your derivatives of these, well, just about anything, but in particular, you need to know the derivatives of sine, cosine, tangent, you know, of the trigonometric functions. You just have to know them. You have to memorize them or whatever. And remember, now in this problem we're going to put that over 1. So now -1 times 3 is -3 tangent squared x, and did we do u? Oh well, we have been doing u, but it's x this time. Alright, secant squared x divided by the square root of 1 minus, now we're not squaring both of these terms, we're only squaring the tangent cubed, which is now tangent to the 6th power. Okay, you can do some arithmetic here. You can change secant to tangent. Matter of fact, you can do that very easily. I want to say it's 1 plus tangent squared is secant squared, but now I'm just going to let it be like that, and this is it right here. Okay, my goodness, if you wanted to, you could change this to sines and cosines, but you know, on a time test, you're not going to have a whole lot of time to do that. So if they're just asking you to find the derivative of this, this is good enough. Alright, so I'm just going to leave it just like this. And remember, we took this chain rule, 3 times tangent squared here. We had to take care of this. That's actually the power rule right here. And then after that, we take the derivative of tangent, which is secant squared. Okay, that is a chain rule on this one. Okay, so that one, it was a little bit more to it, but needless to say, who knows what the College Board will throw at you. So anyway, and there again, I mean, it's reasonable to believe that you could get a problem like this. Okay, alright, so let's do, I want to say one more problem. It's a pretty good problem here. I like this one. But here again, you just have to memorize these, well, these derivatives here. You have to memorize the derivative of the inverse of all 6 of these. And there again, I think probably what I have heard other teachers say is that tangent inverse is probably the most used there. Maybe sine inverse, I don't know. But needless to say, it doesn't hurt to know these. Well, let's do one more. Okay, I think I have one more in mind. Yep. Alright, so let's go with, let's do this. Arc, secant, right, x to the ninth power. We want to find the derivative of that. Okay. And I've been using u, but in the last couple of examples I've used x. We could have used any letter we so choose. Okay, let's go ahead and start with this. I wouldn't want to use e because e is, we use that as a function. Okay, so I try to avoid e. Alright, so let's go ahead. I want to find this derivative. So let's look at it. I want to find secant. There it is. It's 1 over. Alright, u is x to the ninth. Alright, well, I'm going to put that down there, x to the ninth. Alright, times the square root of x to the ninth. How about squaring that? Alright, x to the ninth, and I'm squaring that. Do believe so. Minus 1, and then times the derivative of x to the ninth is 9x to the 8th. Alright, so my derivative will go here. Alright, we're going to have something that we can divide out, so let's keep going here. We've got 9x to the 8th right here, over x to the ninth, and then the square root of, alright, so 9 times 2 is 18, x to the 18th power minus 1. Alright, so I think we've got everything there. Now, just look what we've got here. We can divide out x to the 8th of these, so we can do that and take out 8 of these and leave 1 here. So now that just leaves us with 9 over x times the square root of x to the 18th power minus 1. And that's it. So basically you need to know the derivatives of these inverses, kind of keep them memorized. 1 minus u squared for both sine and cosine, 1 plus u squared for tangent and cotangent, no square root on these. Okay, u times the square root of u squared minus 1 for both secant inverse and cosecant inverse. Okay, and of course now you have to remember at the end you're taking the derivative of u. Okay, and that's what we just did. Alright, that's all I want to cover on the inverses. There, we could keep going, but you see that there is a pattern to all of this, and that's basically all I wanted to do, was establish a pattern with all of this. And just again, keep in mind the derivatives of even cosine or cosine inverse will always have the negatives for the c functions, okay? The c trig functions. Alright, so again, there it is. And by the way, that was probably number 4. Okay, anyway, it does not matter. Alright, this is KP the Math G signing off, and I trust that you will have a wonderful day. I hope this has helped you out. If there is a subscribe button, please click on that and subscribe. I appreciate everyone here. I'll do the best that I can to help you, and we are for right now doing just calculus based stuff. Doesn't mean that I wouldn't do algebra 2 or something else, college algebra or something else. So anyway, alright, KP the Math G is signing off. Have a great day.